In this video, we're going to be discussing trade and specialization and how we can use comparative and absolute advantage to determine who should produce what item and what they should trade in place. So benefits of trade, we've got a couple here. Trade creates value. Through trade, we can move items from those that value it less to those that value it more. So we can exchange monetarily, we can exchange from good to good. So trade creates value by moving goods and services from people that value them less to value them more. Through trade, we can also have specialization. And through specialization, we increase our productivity. And we also increase our division of knowledge. Having a division of knowledge is important. If you think about it in terms of creating your own village, when we have a small localized society, everybody has to do a little bit of everything. Once we're able to actually specialize, what's going to happen is we're going to become more efficient, we're going to become better at what we do, and through this specialization and increased efficiency, we're going to increase our productivity. And through this specialization process, we're going to increase our total collective knowledge through specialization and trade. So now what we're going to talk about is we're going to talk about a hypothetical economy where we only have two goods to produce and trade. So we're going to start by introducing what we call a production possibilities curve. This is going to look a little bit like this. Let's say that we are the USA. And as the USA, we can produce only two goods. We can produce apples, and let's say we can produce 10 apples, or we could produce 10 oranges. So these are our production possibilities. We can produce anywhere along this line. So we can produce at most 1 apple or 10 apples and 0 oranges, or 10 oranges and 0 apples, or some combination in between. We could also produce within this curve, but it wouldn't be efficient to do so. Remember that consumers are going to be utility maximizers. So it doesn't make sense to produce under what we're capable of. For the time being, without trade, we're not going to be able to achieve anything further out than this curve. So let's say that we have two economies, and we're trying to decide of those economies. Let's say we have the US and we have Canada, and we want to know who should produce apples and who should produce oranges. So what we're going to look at here, what becomes imperative, is what do we need to look at to determine who should produce what item? And so I want to introduce a couple of terms here that we're going to work with. The first term I want to introduce is absolute advantage. So absolute advantage is essentially who does it better. So for an output question, it is who produces more. And for an input question, it is who uses fewer resources. So absolute advantage is essentially who does things better, who produces more. Now, typically you'd think that this would be what would determine who specializes in each one, but it's actually got to do a lot more with opportunity cost. So when we're deciding what country should produce apples, what country should produce oranges, we're going to be looking at something called comparative advantage. And comparative advantage looks at this from an opportunity cost point of view, So if you remember, opportunity cost is the value of the next best option. So it's what you're giving up. So comparative advantage, rather than looking at who does it better, who uses fewer resources, what we're looking at in comparative advantage is who gives up less to make that example. So to make that happen, we're looking at who has to give up less in order to produce what they're going to produce. So what I'd like to do now is I'd like to set up a trade and specialization problem. And these problems that we're going to go over, these examples, are going to be very similar to the Jack and Jill comparative advantage problem from your problem set. So please refer to these videos when you go through in calculating our per unit opportunity cost and calculating absolute versus comparative advantage. So I'm going to set up a problem. Let's continue to take this example that we were using before of apples and oranges. So I'm going to create a box here. And in this box, we're going to call this production possibilities. So let's say I have two countries. I have the USA and I have Canada. And we can produce either apples or oranges. So what I'm going to do here, I'm going to generate some numbers. We'll keep our numbers nice and simple for these examples so that we can work them out pretty quickly. So we're going to look at what we call, again, their production possibilities. So we're going to assume that the US can produce 50 apples or 20 oranges. So again, they can only produce a maximum of 50 apples and 0 oranges, or 20 oranges and 0 apples, or some kind of combination of the two. We're going to assume then that Canada can either produce 40 apples or they can produce 10 oranges. Now, what we need to do in order to figure out who should produce apples and who should produce oranges so that we can generate this trade is we have to calculate something called per unit opportunity cost. So in other words, what we're doing here is we are talking about how many apples we would have to spend to make oranges and how many oranges we would have to spend to make apples. So we're putting these two things in relative terms. We're not working with dollar amounts in this example. Instead, we're working with trade. So we're looking at how many do I have to give up in order to produce the other good. So we need to put apples in terms of the cost of oranges and oranges in terms of the cost of apples. And to do this with an output question, we use a little trick called other goes over. So this is an output question. In other words, this is our production. And we're going to call it other goes over. So when we calculate the per unit opportunity cost, what we're looking at is putting these in terms of the other good. So other goes over. For every apple we produce, we have to give up 20 over 50, which is 2/5. And the reciprocal, or this number flipped around, is going to be other goes over 50 over 20, or 5/2. So what this is telling us is that for every apple we produce, we have to give up producing 2/5 of an orange. For every orange we produce, we have to give up producing 5/2 of an apple. So this is called our per unit opportunity cost. So let's go ahead and we'll do the same thing with our production possibilities for Canada. Other goes over, so 10 over 4, over 40 is 1/4. And 40 over 10, other goes over, is 4. So now for Canada to produce apples, for every apple we produce, we have to give up 1/4 of an orange. For every orange Canada produces, we have to give up 4 apples. Now, what does this mean? What do we do with this information? Well, what we're going to look at is we're going to look at who has absolute advantage versus the comparative advantage. And we're going to look at this information, and from this information, we're going to be able to calculate who should produce apples and who should produce oranges and who should trade for the other good. So absolute advantage is, again, who does it better? So this is an output question. So when we're talking about who does each of these goods better, we're going to isolate and we're going to look at one good at a time. So let's look at apples. We know that the US can produce 50 apples, Canada can produce 40 apples. Who does it better? So because the USA does it better and produces more, US is going to have the absolute advantage in apples. So absolute advantage for apples is going to be the US. We're going to follow the same standard here. The US can create 20 oranges and Canada can produce 10. So again, the absolute advantage in oranges is also going to go to the US. Now, you'd be surprised to know that this isn't actually what we're going to be using to generate who should specialize in apples and oranges. Just because the US does both of these things better and has the absolute advantage in both of these goods doesn't mean they can't benefit from trade and specialization. Instead, what we're going to be looking at is not how many they can produce, but how much they have to give up in order to produce that particular item. So when we're looking at comparative advantage, what we're looking at is our per unit opportunity cost. So now when we're looking at our per unit opportunity cost, what we're looking at is who has the lower opportunity cost for producing apples and oranges. So now, rather than comparing their total outputs, we're going to compare their total per unit opportunity cost. And the one with the lower per unit opportunity cost is going to produce that particular item. Now, in all of our examples that we'll be using in this class, one individual will produce one thing while the other individual produces the other good. So now we're going to go back and look at our per unit opportunity cost and compare the US and Canada in terms of per unit opportunity cost for apples and oranges. So we're going to compare now. For every apple the US grows, they have to give up 2/5 of an orange, versus for every apple the US produces, Canada produces, they have to give up 1/4 of an orange. Who gives up less? Well, 1/4 is less than 2/5. So Canada is going to produce apples, and we're going to look at this same example for deciding who's going to produce oranges. For the US, each orange costs 5 halves of an apple. For Canada, each orange produced cost 4 apples. So in this case, 5 halves is less than 4. The US has to give up less apples than Canada does in order to produce oranges. So now, based on this information, we can determine our comparative advantage. So in apples, again, comparative advantage looks at opportunity cost instead of absolute advantage, which looks at overall production. So in this, for apples, Canada has the comparative advantage. And for oranges, we have the USA has a lower per unit opportunity cost. So the US has the comparative advantage in oranges. So what this tells us is that, again, when we are determining who should specialize in what, we're not looking at who's better. We're looking at who gives up less. So in this case, whoever has the comparative advantage in each good should produce that good and trade it for the other. So ultimately, the US is going to produce oranges and trade for apples, and Canada is going to produce apples and trade for oranges. There's several problems in the textbook as well as in your problem set that have to do with output questions such as this one. And I'd like to go over the flip side of this problem, which is instead of talking about production and producing apples and oranges or producing any goods other than those, what we're going to be looking at instead is who uses fewer resources. So I'm going to change the style of this problem just a little bit. And now let's again use our examples of looking at US production. So let's look at the USA and let's look at Canada. And now, rather than trying to figure out how many we're going to make, we're going to go ahead and we're going to hold this constant. So let's have us produce phones and bikes. So Canada and the US are going to produce one phone or one bike. So this is going to be an input question. And with an input question, what we're looking at is not who can produce more, but how many resources have to be used. So in this case, the fewer resources that have to be used to create either one phone or one bike should be the lowest number. So for this kind of problem, what you're going to see is some sort of unit of measure. So to produce one phone, let's say that it's going to take the US 50 hours, while it will take Canada 40 hours. So one iPhone is going to take inputs of 50 labor hours for the US and 40 labor hours for Canada. So this is going to be what is required to make one iPhone. So again, we're looking at the inputs, not the outputs. So a way to look and see how these questions are different and how to be able to recognize an input from an output question. An input question will have some sort of unit of measure inside of the boxes, and our output will be locked. So rather than varying our output, saying the USA can produce 50 phones and 10 bikes or whatever you want to put it, we're looking at inputs into the production process to create one phone, or one bike. So let's fill in the rest of this. Let's say that it takes 20 hours for the US to make one bike, and let's say it takes 10 hours for Canada to make a bike. Now, for input questions, we have a different trick. So just like we calculated the per unit opportunity cost for our output question, we're going to do the same thing here. But when we're working with inputs, our formula is a little bit different. So for input questions, it's other goes under. To calculate the opportunity cost of iPhones in terms of bikes, other goes under, so 50 over 20 is 5/2. The reciprocal, other goes under, so 20 is on top, 50 goes under, and the broken down version of that is 2/5. So for every one iPhone the US produces, they give up producing 5/2 of a bike. For every bike the US produces, they have to give up 2/5 of an iPhone. We do the same thing here with our Canadian per unit opportunity cost. Other goes under, so 40 divided by 10 is 4. And the reciprocal of 10, other goes under, 10 over 40 is 1/4. So now we follow a very similar process as we did with our output question, except now our terms are going to be reversed a little bit. So first, we're going to look at absolute advantage. So for our absolute advantage, when we looked at our output question, we were looking at who produced more. For an input question, we're looking at efficiency, and we're looking at who needs to use the fewest number of resources to produce our output. So again, we're going to be comparing Canada to the US. So looking at our iPhones here, we can see that it takes the US 50 hours of labor inputs to produce one iPhone, whereas it takes Canada 40 hours to produce one iPhone. 40 hours is less than 50 hours. So in this case, Canada has the absolute advantage in iPhones. So Canada should iPhones. And comparing the same thing here again, it takes the US 20 labor hours to make one bike. Canada, it takes only 10 labor hours. Again, Canada has a more efficient process. They use less inputs than the US. So once again, our absolute advantage for bikes is also going to be Canada. Now again, just because Canada does both things better doesn't mean they won't benefit from trade. So now, again, going back to comparative advantage, this is where we need to look again at our per unit opportunity cost to determine who should specialize in bikes and who should specialize in iPhones. So in this, we're going to once again compare our per unit opportunity costs between the US and Canada, remembering again that for the US, for every iPhone produced, it's going to cost the US 5/2 of a bike, whereas Canada, it will cost them 4 bikes. So we're looking for the lower opportunity cost. So in this case, our comparative advantage goes to the US. So iPhones is the US. And we'll compare the same thing here. We'll compare for the US, it costs 2/5 of an iPhone to make one bike. For Canada, it cost 1/4 of an iPhone to make one bike. 1/4 is less than 2/5. So therefore, Canada has the comparative advantage in bikes. So, since we're looking at opportunity cost, our per unit opportunity cost, we're following with our comparative advantage, and we're going to determine based on that comparative advantage that the US should produce iPhones and Canada should produce bikes. Again, this is very similar to some of the textbook questions that you'll have at the end of chapter 2. And if you need more practice with this, this will be in our Jack and Jill problem in your problem set. That is all for this video. Thank you for watching.